Hello everyone, this is my review of the AMC12B from 2023, which is at the time of recording either 2 days or 3 days ago, depending on your time zone. I think that for some of you, you have already checked your answers, but there's already something there which I think is worth saying with regard to checking answers. Now, you may have noticed that the answer options are a little bit scrambled up this time. So for example, in question 2, it goes 46, 50, 48, 47, 49. This is an anti-cheating measure that the MA put in place for the AMC10B and 12B. This is because, as some of you are aware, there were some leaks before the AMC10A and 12A. And so in order to make sure that even if there were leaks, that memorizing the letter answers would have been useless, they just scrambled the answers and they scrambled it differently for different testing locations as well as both online and on paper. So there were different online versions and there were different printed versions. This would mean two things. One is that the results may be a bit delayed, but secondly, it also means that when I tell you that, let's say the answer is option B, 50, for instance, please be aware that the answer is 50, but it may not be option B for you. 50 could be option E for you, it may be option A for you. So I've just got a reference set of answer options based on one of the copies of this AMC12B. But the ordering would be potentially different for some questions wherever you took it. Now, just like the AMC10A, I am only going to go through the AMC12B. There is quite a lot of overlap with the 10B, so I shall do 10A and 12B, as is usually a habit. And also, from my time as a student long ago, I used to always do the AMC10A and 12B. So that's what I'm doing here again. Right, so without further ado, I'll get into the questions. This is a semi-live solve in the sense that I have got a list of answers next to me just in case I say anything wrong. But it is also semi-live in the sense that I've not really tried most of these questions before. So if I'm saying anything silly, don't hesitate to let me know in the comments below. All right, question 1. Orange juice into 4 identical glasses. There are 3 full glasses, and then the 4th glass is 1/3 full. Now you want them to have the same amount of juice, so the total is 10 over 3 divided by 4 is 10 over 12, which is 5 over 6. So 5 over 6 is the target, which means that all of them should have 5 over 6. When you pour from each of the first 3 glasses into the 4th glass, your answer is just 1 minus 5, 6 is 1/6, which is option C on my copy, but not necessarily option C on your copy. Nonetheless, the answer is uncontroversially 1/6. So I will just mention the answer at the end, right? I will sometimes say the letter name, but don't be too concerned with the letter behind the answer. Question 2. Went to buy running shoes. They were on sale with a 20% reduction, but a 7.5% sales tax. So it went from 100% to 80% of the original price, but then you have 7.5% of this. So 7.5% of this, 7.5 over 100 is equal to 15 over 200, which is 3 over 40. So 3 over 40 of 80 is 6, so it ended at 86%. So 86% of the price has to be at most $43. And obviously this means that dividing by 43, 2% is $1, 100% is $50. So this would be the maximum price before discount. So answer is 50. Question 3. 3, 4, 5 right triangle, 5, 12, 13 right triangle is inscribed in circles A and B. Ratio of the area of circle A to the area of circle B. Okay, so when it comes to right angled triangles in a circle, the key thing to note is that this would be the diameter of the circle. So if you have got, this is not very to scale. If you have got something like this, it means that the hypotenuse would correspond to the diameter. So the ratio is just 5 squared is to 13 squared, which is 25 over 269, because area is proportional to the square of the radius, but also we can say the square of the diameter. Question 4. Unit conversion. This is very, very error prone, so please be very careful. Jackson's paintbrush makes a narrow strip with a width of 6.5 millimeters, enough paint to make a strip 25 meters long. How many square centimeters? So now 1 meter is 100 cm and is 1000 mm. Milli means 1 in 1,000, centi means 1 in 100. So that's why century is 100 and millennium is 1,000. So little bit of um, Latin or Greek history explains all of this, but let's not concern ourselves with that. 6.5 mm times 25 meters is therefore 1 meter is 100 cm, and 1 mm is 1/10 of a cm. So it's going to be 100 times 0.1 is 10. So your answer would be 65 times 25. I'm sure that's 1625, right? It surely has to be because, yeah, there are no extra zeros, there are no decimal places. So this should be it. Question 5. 2 by 1 rectangle covers 2 adjacent squares of a 3 by 3 grid. You're not told which 2 squares are covered. Your goal is to find at least 1 square that is covered by the rectangle. What's the minimum number of turns that you need to ensure that at least one of your guessed squares is covered by the rectangle? Now, my instinct is immediately that I want to just guess a checkerboard like that. Essentially, you want to block off the possibility that you miss the 2 by 1 rectangle entirely. This is like a battleships game in a way. And I think that should be it, right? Because if I only have 3, like let's say if I say there are these 4 locations, I need to at least cover 1 square in each of these 4 locations. So minimum I need is 4, and I've already got 4. So the answer is option C, or just 4. Question 6. When the roots of the polynomial here are removed from the number line, what remains is the union of 11 disjoint open intervals. Of course, the roots are just 1 to 10. On how many of those intervals is px positive? Okay, so here's how I like to do it. I shall not be lazy today. I shall just write 1 to 10 because I think that is when we have got a small number, we can just write everything down. So there are 11 intervals. Now, when x is huge, everything is positive. So that's straightforward. I will just put a pair of pluses here to indicate that that region is one of the positive intervals. Now, when you cross over one of these boundaries, this is how we solve polynomial inequalities given a factorization. We can just see that the x minus that value is the thing that switches sign. So when you cross over x minus 10, that is still going to be positive because this is an even power. But when you cross over, let's say x minus 9 to the 9, that negative to the power of an odd value will give you a negative sign. So that will change the sign here to be minus. And then when you cross over 8, it stays the same. So you're going to get something like this. Every time you cross an odd, you change the sign. You cross an even, it does not change sign. And just a sanity check, when x is less than 1, uh, everything will be negative, and there are 1 to 10 sums up to 55 as odd. So it should be negative at the end. I've not messed up. So I see 6 intervals where px is positive. So that should be option C. Question 7. For how many integers n does the expression here represent a real number? be very careful with this because this is not complicated at all. This just needs to be a real number. And to be a real number, it just means that you have to check everything is defined. Now, everything is defined. Condition number one is that n has to be more than 1, more than or equal to 1, so that the logarithms are all log of a positive value. So that's the condition 1. Second condition, I remind myself that log n minus 3 cannot be 0, which means that n should not be 1000. The third condition is I need to make sure that everything is in the square root, cannot be negative. So that's the thing to check. Log n squared is 2 log n. This has to be greater than or equal to 0. Okay, so if I were to just call log n x, let's replace all of this by x. And I multiply both sides by x minus 3 squared. Then we get something that's vaguely like the previous question just before this. I usually like to just put it all in the same form like this. And so now I can say that, all right, x minus 3 squared does not affect the sign. So it's basically 0 and 2 that's the issue. So when x is 0, the thing is negative. So when x is not 0, when x is between 0 and 2, it is negative. And then when x is more than 2, it's positive. When x is negative, well, x can't be negative. Okay, so let's check. This means that I have got between 0 and 2, which I feel like I may have messed up. But let me write it down, then I'll check if I have messed up. I'm saying that log n is between 0 and 2. Yeah, this looks off. I'm not sure why. Because it looks like none of the options. Let me just check whether I've actually typoed anything. I'm doing this manually. There's a chance that I have typed something wrongly. So let me just take a quick check that I have. If I've not typed anything wrongly, then you're probably shouting through the screen, hey, no, you messed up something. Oh, right. I multiply x minus 3 squared to both sides. So there's no square here. Yep. That's the mess. Okay. So we're fortunate that the answer options have been quite unambiguously not going to trap me, because I ended up with something like 99 or 100, which is not here. So this makes sense now. I actually am supposed to be between 2 and 3. Felt more likely to be correct anyway. It can't be 3, so it's actually a strict exclusion. So n goes from 100 to 999. But we need to be careful, right? And this is a bit of a very, very obviously annoying question. Down here, I've got 900 solutions. I realize that I also have to include the boundary value down here. Right? It is possible that x is 0, meaning n is 1. So that gives me one more value. And I am quite sure that that should be the only issue. So it should be 901. So a comment that I've heard, and of course I'm doing this now semi-live, right? A comment I've heard is that this paper has a lot of potential for silly errors, careless mistakes. So if you scored a bit lower than you expected, you are not alone. It is a very, very like temperamental kind of paper where a lot of times if you just misread one word or you miss a certain phrase, then you are going to be wrong. And answer option is there to catch you, and the jumbled up sequence of the options doesn't really help. It's even more confusing. So a lot of weird mistakes happen. And don't be too alarmed if it happened to you once or twice. Just hopefully not like 5 times. Question 8. Non-empty subsets B of 0 to 12 have the property that the number of elements of B is equal to the least element of B. Okay, I think I see what's happening. So if I pick 1, then I can only have one thing. If I pick 2, I can have 2 things. If I pick 3, then I can have 2 more things. If I pick 4, I can pick 3 more things, and I realize that, okay, this is going to follow a pattern. This is just one way. This is 10 ways. This is 9 choose 2. This is 8 choose 3. And it just follows along. So I can go 7 choose 4, 6 choose 5, and just add them up. I was waiting for some clever combi identity to show up, and then I realized that nah, it's not going to happen because this is just sorry, I mean it may happen, but it's not necessary. So 1147, 103 plus 41, so 144. Uh, I have a feeling that this follows some kind of a recurrence. I feel like this is a Fibonacci pattern as well, because 144 is a Fibonacci number as well. So it sounds a bit recurrence-like. I would just do this and move on in the AMC, but feel free to think about it, whether it's actually a recurrence and whether it actually follows the Fibonacci sequence if you started off from some smaller cases. All right, so question 9. What's the area of the region in the coordinate plane defined by this equation here? It's a little bit annoying, but the first thing that we can say is that you realize that this is going to be symmetric about the x and y axis. And so if it's going to be symmetric about both the x and y axis, we would be able to simply draw the first quadrant and focus only on a much more reasonable looking portion. So only focus on the first quadrant and multiply by 4. Now, this is basically centered so-called at 1, 1, and it means that your distance in the x coordinate and the y coordinate from here is all together at most 1. So you can go up here, 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 and basically you get this diamond shape here. Now this diamond shape here has area 2, and you're actually just going to make 4 copies of it. So it's going to be this rather interesting looking shape when you actually reflect it all over. But area-wise, that would just be 2 times 4, which is 8. Again, on the xy plane, this time you have got a circle of radius 4. If center, I believe this is a typo on my part. On the positive x-axis is tangent to the y-axis at the origin. So it just means draw this. And the circle of radius 10 with center on the positive y-axis is tangent to the x-axis at the origin. So this is a bigger circle. What's the slope of the line passing through the two points at which the circles intersect. Okay. Now, there are a couple of ways to do this, right? The point is that, of course, we know this is 0, 10 and 4, 0, and this is the origin. If you wanted to just solve for the second point of intersection, that is entirely possible. It's not especially hard because you can just um, eliminate a variable and solve. So if let's say that I call this xy, then it would look something like x minus 4 squared plus y squared equals to 4 squared. And then you have got x squared plus y minus 10 squared equals to 10 squared. If you were to then expand this out, and you were to now just compare these two, whether by subtracting or just by staring at it, it's pretty clear that 8x is 20y. So y over x is 2/5, which would be your answer because that's the slope of the line would be y over x. This is one option that would be quite nice. Another option would be to simply note that by symmetry, it's going to be perpendicular. This green line that we're finding is actually the radical axis of the pair of circles, and it would be perpendicular to the line connecting them. So the gradient of this red line connecting the centers is negative 10 over 4, which is minus 5 halves. Correspondingly, that means that the slope of the green line that we want would be 2/5. So as you can tell, both of these methods would take roughly the same amount of effort. One's observation, one's just computation. Okay, on to question 11. What is the maximum area of an isosceles trapezoid that has legs of length 1 and one base twice as long as the other? Let's just find the area. Don't have a better suggestion? So this is half x, the middle portion is x, 1 minus 1/4 x squared, and so your area is equal to just the height times the average of the two bases. I shall just take out the half from here and the half from there. And I take the 3 as well. So I guess 3/4 x root 4 minus x squared. Now, this is something that can be handled in a few different ways. If you want to get the maximum of this, one way is to simply differentiate if you are calculus inclined. Another way to do this would be to use trigo substitution, which I am tempted to do here. So I will just let x equals to 2 cosine theta, so that the root 4 minus x squared is going to be 2 sine theta. Now this would then become just 3 sine theta cos theta, which is 3 halves sine 2 theta, and the maximum would therefore be 3 halves. The other way to do it, which would be kind of more algebraic, would be via AMGM, because this is just less than or equals to 2. So same conclusion, 3/4 times 2 is 3 halves. So this would be by AMGM or by a trigo substitution. It appealed to me to do trigo because I wrote it like this. If you brought this x into the square root, then I think AMGM would be very natural instead. Question 12. So this circle binary operation just means that for complex numbers, multiply together the real part and the imaginary part separately, which I think to most of us doesn't really seem like any meaningful complex number operation. Perhaps it is, but it certainly is not something that we can see in a few seconds. So we can just go straight into z equals to x plus yi and just throw this straight in. It tells you that circle z is z squared plus 40, means x squared plus y squared I is x plus yi squared plus 40, which is something that is quite easy to simplify, right? But x and y are real numbers, of course, the real and imaginary part respectively. If I cancel this off, I get the y squared equals to 2xy and y squared equals to 40, which is a very exceptionally boring conclusion. Y is not 0, so it just means y is root 40. X is half of that, 2 root 10 and 10. And modulus of z is square root of 10 plus 40, which is 5 root 2. I didn't mention plus or minus, but that would not affect the modulus here, right? So it could be technically plus or minus, but no harm done. Answer should not change. Question 13. Rectangular box P has distinct edge lengths ABC. The sum of the lengths of all 12 edges is 13. The sum of the areas of all 6 faces is 11/2, and the volume is half. This sounds very familiar. I feel like I've seen this in the AMC a year or two ago, or AIME. If you recognize what question this is, let me know. I can't really check during this video right now. As I said, this is a semi-live solve. I just think I've seen it before, right? Sometime last year, I remember explaining that we can use Vietas, so this certainly looks like it's still true here. Right? Do I need to use Vietas though? I don't see why we need to use Vietas. This is very peculiar. So let me just check, right? A plus B plus C is 13/4. AB plus BC plus CA is 11/4. And what do you want? You want the longest interior diagonal. That's just the two opposite vertices diagonally. Length is just this, right? So unless I'm misunderstanding something, you just go 13/4 squared minus 2 times of 11/4. This is computationally a bit annoying, but this does not feel like it's very hard at all. Yeah, it's 9/4. And this is redundant. Okay, a rule of thumb with respect to redundant information is that you should probably find out by reading again whether it's supposed to give you any restriction. So this says not the length of the longest possible something, it's the length of the longest interior diagonal. So ABC would be fixed by this because by Vietas, ABC are the roots of a certain cubic polynomial. So ABC are fixed, and what you are supposed to find is fixed. So if you're able to find it without using all the information, that's okay. This is not a case where you need to select and satisfy conditions, in which case you also need to make sure that you are satisfying that. So slightly different situation here. It's okay to have the redundant info. Now I'm feeling a bit of deja vu again, like the AMC10A, in which the difficulty is not really going up that much, right? It's kind of flat. I think generally this year's AMC is such that the back end is not that much harder than the middle, as compared to what we have seen in previous years. So let's continue looking and see if that's true again. For how many ordered pairs AB of integers does a polynomial have three distinct integer roots? Well, we just said vietas, now vietas again. The roots, let's call them PQR. They're not primes, even though PQR often refer to primes. PQR multiplied to -6. Now, every combination of roots will give you a different AB, because a different combination gives you a different factorization. A different factorization cannot give you the same polynomial. So I just need to list out the possibilities. Basically, the 116 and 123 are the possible combinations of magnitudes, and then the negative sign is going to be there to be a minor nuisance of itself, because you can have 1 minus 6, 1 minus 1 6 here, and then 1 2 minus 3, 1 minus 2 3, and minus 1 2 3 as the possibilities. So there are 5 combinations. Each combination gives you a different A and B. So your answer should be 5. On to question 15. This is a little bit less instant because of the fact that it has a lot of things to read. A, B, C are positive integers such as this is true. I immediately just want to multiply by 210. I see no reason to delay doing that. So 14 times 15 is 210. So this is convenient. Statement 1 says, if GCD of A and 14 is 1, or GCD B and 15 equals to 1, or both, then GCD of C and 21 is 1. Let's think about that. So if A is co-prime to 14, that means that this is going to be divisible by 14, which means 2 and 7. This is not divisible by 7. So if this is true, it would not be divisible by 7. But I don't see why it wouldn't be divisible by 3, right? Is this or both? So I feel like this is not true. And just as an example, if I just use A equals to 1 and B equals to 3, C would now be a multiple of 3, which is not co-prime to 21. So option 1 is false, and that eliminates A, B, and C here, which technically means that I only need to check statement 2. I don't even need to check statement 3, technically. Now, statement 2 says, if GCD of C21 is 1, then GCD of A and... Did I typo that? Let me check. I feel like, again, for the second time, may have made a typo. Let me just double check this. Yeah, this is all very manual, right? And a bit thrown off by the fact that the answer options are all scrambled, and this year's paper is a little weird looking aesthetically. Yeah, that was a typo. It's 14. Okay, so in that case, if GCD A 14 equals to 1 or GCD B 15 equals to 1 or both, that means that this is just the reverse of the previous statement, right? If GCD C21 is 1, then one of these would be true, at least. Well, we can take the contrapositive. The contrapositive is that if GCD A14 is not 1, and the GCD of B and 15 is not 1 either, then the GCD of C and 21 is not 1. Is that true? So if the GCD of A and 14 is not 1, then it could have a common factor of 2 or 7. If it has a common factor of 2, then C would be even, but not necessarily does it have a common factor of 21. But here, if the common factor of GCD of B and 15 is not 1, so B has a factor, then again, that could be 5. So let's check, right? If A is equal to 2 and B is equal to 5. Then in that case, if A is 2 and B is 5, 30 plus 70 is 100. So the GCD is 1, but neither of these are true. So option 2 is wrong, which means that it should be option 3 only. Did I read this right? Oh no, wait. Okay, my apologies. I am looking at the question again and I realized that this is actually 210. So that goes down completely the different direction. If it is 210, then I guess my logic would be that no, it is going to be true. So let's rewind back a couple of minutes uh, and say that if this is 210, it is now it's true, right? So if the GCD of A and 14 is not 1 and the GCD of 15 and B is not 1, that means that you are going to get a common factor with 210 because that's 14 as 15. So my bad. Uh, this is true. And this is, let's check option 1 again with this new statement, this new number 210, which now 21 would have been a good question. I feel that 210 is a weirdly more boring question, which is oddly enough something that I solved by accident. So if the GCD of A and 14 is 1 or GCD of B and 15 is 1 or both, then the GCD of C and 210 is 1. I don't know. Uh, yeah, it's not true, right? Because I mean the example still works. I think the GCD, yeah, in this case the GCD of A and 14 equals to 1, but the GCD of C and 210 is not 1. So what I've done here is still correct. It's just that this should be actually 1 is wrong, 2 is correct, and I don't need to check 3. So apologies for the confusion that is coming from typing the question wrongly. Uh, but the logic, I hope I have made it somewhat clear, is that if you think it's false, come up with a counter example. And for the second one, why it's true is by flipping the contrapositive, the common factor of A and 14 would then appear as a factor of the whole left-hand side. So that would be the common factor of C and 210 as well, which is why it is actually true. Question 16. The state of coin land. Coins have values of 6, 10, and 15. X is the value of the most expensive item in coin land that cannot be purchased using these coins with exact change. What is the sum of digits of X? Okay, now this is something that we call answer extraction. It's not that you care about the sum of digits of X. It's more that, well, you do X and then after that, they don't want you to just check them one by one, so they ask for sum of digits instead. This is corresponding to the so-called chicken McNugget theorem because it refers to different fixed quantities. Can you combine them to get everything? Answer is no. but at some point henceforth, all of the positive integers would be attainable. So it makes sense to have a most expensive one that cannot be exactly purchased. Now, 10 and 15 can give you all multiples of 5. And that's actually all I'm going to do. So all multiples of 5 can be attained. And basically this means that you can get multiples of 6 and add them to all of these and it will cover everything. So 10, then after that, this whole chain. 15, and this whole chain. 20, so just write them all down. Now, once you start to list out all this, of course, the multiples of 6 themselves sort of gives you a slight tail in this row. But basically, this exhaustively listing it out is going to give you all of the possibilities that you can attain. And I realized that I can't count. This is 41. Now, notice what's happening here is that you are getting all of these numbers. And so effectively, beyond this point, you're going to get everything. And so the last one that doesn't work is the one that ends here, 24 to 28. You have a gap of 29 before you get to 30. 29 is very obviously not possible to get using 10, 15, and 6 as well. The more surprising thing is that everything else after that can all be attained. So 29, 2 plus 9 is 11, should be our answer. Yeah, sorry if I didn't explain this very well. Basically, all I'm saying is that 10 and 15 gives me this bunch of values. I don't need to continue until 40 because I already know that 40 will appear later on in the row containing 10. And that's the reason why I just write down 6 values and then I just write these rows of different classes modulo 6. Okay. Question 17. Side lengths are in arithmetic progression with shortest side of length 6. One of the interior angles measures 120 degrees. Now, first of all, the longest side will always be opposite the obtuse angle because the obtuse angle must be the largest angle. So that means I know at least how to draw it. I want the area of this triangle. What I need to do is to solve for x. Use the cosine rule. This is fairly routine, so I'm just going to write everything out. I don't expect any surprises unless the quadratic is going to offer some nice outcomes. If not, it would just be a fairly routine exercise. So cosine 120 is negative half. That cancels with the negative 2. So let's just gather everything. 3x squared, 24, 12, 6. So 6x. 36 here, there's 36, 36, 36. So minus 72 equals 0. X minus 4, x plus 6 equals to 0. So okay. So this is going to be x equals to 4. And this is a 6, 10, 14 triangle. area, just use half AB sine C. So 15 square root 3 is our answer to this question. Question 18. I really hope I did not make a typo here on this question, which because that would be very unfortunate. Let's assume it's okay. Last academic year, Yolanda and Zelda took different courses that did not necessarily administer the same number of quizzes during each of the 2 semesters. Yolanda's average on all the quizzes she took during the first semester was 3 points higher than Zelda's average on all the quizzes she took during the first semester. Yolanda's average on all the quizzes she took during the second semester was 18 points higher than her average for the first semester and was again 3 points higher than Zelda's average on all the quizzes Zelda took during her second semester. Which one of the following statements cannot possibly be true, and then a bunch of things on averages? Now, this actually is a question that is, I think, pertaining to a phenomenon known as Simpson's paradox. This is something that you can do a quick search as well. Simpson's paradox is basically saying that you can have a better average in the first, in this case, semester, right? But let's say in the first half of a certain process, you can have a better average in the second half of that process than someone else, but overall still be doing worse. And the reason is that if the number of games here, or the number of quizzes, or the number of items in the sections are not the same, then it doesn't mean that the one that is higher throughout will always win. So let's just see how that will work here and see what cannot be true. Right? So in semester 1, the average was x and x plus 3. Sorry, x plus 3 and x, right? Yolanda's average is higher. Then it was 18 points high. Oh no, sorry, 18 plus 3, 21. X plus 21 and x plus 18. So these were the averages. So which one cannot be true? Well, that's just the first one, right? The first one cannot be true because your best score average is x plus 21 and x here, you can't be 22 points higher because the best case scenario is that Yolanda did only one quiz in the first semester and everything in the second semester. So that means that her overall average is at most x plus 21. And for Zelda, her overall average is at least x. So it can't be 22 points higher. So that certainly is false, right? But the other things are pertaining to basically Simpson's paradox, right? Zelda could have gotten higher if, let's say, she had a lot of x plus 18 average quizzes, whereas Yolanda had mostly x plus 3 average quizzes. So that is possibly true. Yolanda's average was 3 points higher than Zelda would be very believable if they just had one quiz each, for example. Likewise, E could be believable, D could be believable as well if the numbers are appropriately chosen. You could end up with the overall average being, let's say, x plus 17. So they could be equal. And the only one that cannot be is 22 points higher. Question 19. Each of 2023 balls is placed in one of 3 bins. Which of the following is closest to the probability, that's important, closest to the probability that each of the bins will contain an odd number of balls? So, if you were to look at this closest to the probability, the idea is simply that your odd and even are kind of equally likely if you have a lot of balls. Each scenario is equally likely. So you've got one of three bins, and there are 23 balls. So your combinations are going to be combinations that sum to an odd total. So all odd or one odd, two even. But the one or two even can appear in three different cases. Now, these are not actually equally likely, and it's not necessarily equally likely without doing a calculation, but they are very close to being equally likely, right? These three are definitely going to be equally likely because it's just permutations of each other. The first one is around the same. So if we are estimating, it would just be 1/4. There are ways to actually calculate this exactly, but that's not what we're being asked to do. Okay, question 20 again feels like something I've seen before. I can't remember where. That's because I feel like I've seen it on multiple occasions before. So not the most interesting question if you have seen it before, but if you have not, it is an interesting question, just that it's not the most original. The reason is that all you need to do is to realize that the first direction is irrelevant, right? Let's say you start here, and after one jump, does it matter where you're at? No, it does not. Now, less than 1 unit away means that you want to be back in this window here. So where would you end up going back? It would be wherever the location is that would be 2 units, but still landing within the circle. So how far can you go would be if I were to draw another circle and you say, okay, if let's say that I jump, I could end up down here. That's okay. If I end up here, that's okay. If I end up here, that's not okay. So what do I need? I need to know what is this angle here out of the whole thing. And let's just see what's happening. This is 1. This is 2. So these are all 2 as well, which means that I can use the isosceles triangle. This is 1/2. So this small angle down here is the sine inverse or arc sine of 1/2/2, which is the arc sine of 1/4. That's half of the angle. So your probability is going to be 4 times of this over, I want to say 360 degrees, but I see a pi here, so obviously uh, it's using radians. So that's the default, right? The default is uh, your sine inverse and cosine inverse would be in radians. So 2 arc sine 1/4 over pi looks like it should be the correct answer. Question 21. A lampshade is made in the form of a lateral surface of the frustum of a right circular cone. I don't know if a picture was provided in my classes. Just before it, I gave a question involving a frustum, but I think I am unsure whether a frustum is supposed to be like a well-known shape. Anyway, you can kind of infer that it just means that you have got something like this, because that's a lampshade, right? That does make sense. The height is 3√3. The top diameter is 6, so this is 3. This is 6. A bug is at the bottom, and there is a glob of honey at the top, and it wants to crawl there. So it's on the furthest place. So let's say here and here. It must remain on the surface of the lampshade. Now it's quite clear I don't see any alternatives. It's quite clear that it just must go in a straight line. Now, the only question is, of course, what does a straight line mean in the context of this lampshade? And the answer is that it can go up like that. But is that the only way up? Let's see what that length would be first, right? So if you had gone straight across, what is that length? Well, I think it's good to just extend it to a full cone, right? The first term shape is a bit confusing. So extend it to a full cone. And also, I can draw the triangle to be front view of it. Oh, wait. In the form of the lateral surface. Okay. Ah, so it has to just okay, I see. It has to just crawl up and go around. So my bad. I didn't read the word lateral surface. That's important because it means that all you can do is to either crawl up something like this, or maybe it's possible to, let's say, crawl up here and do a little bit. So that's actually kind of the question, right? Like, how do you want to move when you are moving from the bottom to the top? That would determine how far you're actually going to go. Now I'm thinking about unfolding this. Now, if I unfold this, I'm going to end up with just something like this. But I want to know the exact information when I unfold it. Maybe I should just unfold the whole cone, right? That actually I think is easier. Okay, so let's unfold the whole cone. By similar triangles, this whole thing is 6 root 3. This diagonal length, this is 6 root 3 and this is 6. Then this diagonal length here is also going to be 12, which means that I have not drawn it to scale once again. This is actually going to be an equilateral triangle from the front view. So from the front view, it looks like that. From the perspective of unfolding it, it means that when you unfold it, you're going to end up with a sector of radius 12. Right, corresponding to this 12. And the base circumference is 12 pi. sorry, this is 12, which means that actually all you have got is a semicircle. So this actually would be a semicircle folded into a cone. And if this is a semicircle, that explains a lot. Because I'm now cutting it in half. So this is not even going to be 12 once again. This is going to actually be just 6, 6, 6, 6. And you are looking at this shape here. And you want to get from here to here, which would not actually work in terms of going in a straight line because you'll be going through thin air. So I can't go in a straight line, but I can go in the closest thing to a straight line, which is to go at right angle in a tangent line and then after use this arc. It seems to be the best path. So let's just check what that would look like. If this is 12 and I use this, this is 6. This would be 6 root 3. Thinking that looks like E, right? The tangent line here will be 6 root 3. This little bit here, this is a 30, 60, 90 triangle. So this small angle is 30 degrees. That would be pi over 6 times 6. Oh, that's just pi. So it will be 6 root 3 plus pi indeed. And since that's one of the options, that seems to be correct. A quick look also tells me that I definitely needed to use a bit of pi. I can't have not used it, and the other two are definitely bigger than this. So if the other two are bigger, then I don't need to worry whether I can achieve that because this is actually shorter. Okay. Question 22. Real valued function f has this property. That looks like a cosine sum to product, doesn't it? It does, right? It looks like cosine. Yeah, it does look like cosine. Okay, so it looks like cosine because cosine A plus B plus cosine A minus B is 2. Yeah, 2 cosine A cosine B. So it looks like cosine, but of course they ask you which of these cannot be the value of f of 1. Okay, first things first, what I can see is that I can eliminate a few options because all of these are attainable. Because f of x could be cosine x, means that it can also be cosine, let's say, pi x would also work because you're just scaling everything up by pi, which is not going to change the validity of the identity. It can be, let's say, uh, negative. Actually, no, I can't use negative, but I can scale the thing, right? So if I want to scale it to give me a 0, cosine pi over 2x would have worked. If I want to give myself a 1, I could have used cosine 2 pi x. So all of these would be valid possibilities, and so A, B, and C can be values. Now what I need to decide is between 2 and minus 2, and honestly, I have no idea. Let's put some values, right? Let's try just putting in some values. The usual practice, let's put 0. So AB being 0 gives me f of 0 plus f of 0 is f0 times f0. Okay, so f of 0 equals to 0 or 1. Now, if f of 0 equals to 0, then letting b equals to 0 would immediately just give me 2fa is 0. 2fa is 0 is probably about your sentiments of two-factor authentication. 2fa is equal to 0, being that f of everything is 0. So that's not a very interesting case. Now, if f of 0 is 1, then let's see what we can do. F of 0 is 1 means that if I put in b is 0, no, that gives me nothing. So don't want to do that again. If I let a equals to 0, I get 2f. So I just get f is odd. If I let a equals to b, that will also make 0 appear. I get f of 2a equals to, sorry, f of 2a plus 1 equals to 2f of a squared. I don't know what to make of that. Let's try a equals to negative b as well. Now you just get the same thing, right? If you put a equals to negative b, exactly the same thing happens. This does look like the cosine function, right? F of 2a plus 1 equals to 2fa squared. That's cosine for you. Cosine is also an even function. So this all looks familiar. Now the question that we have is, what does this actually allow us to restrict about f of 1? Like, what makes it possibly 2 but not minus 2 or vice versa? So let's think about this for a second. Oh, yeah, it just means it can't be too small, right? So f of 2a equals to 2f of a squared minus 1 is just greater than or equals to minus 1. Okay, well, I was looking for something more clever than that, but this just tells you that minus 2 doesn't work, right? So, sorry, minus 2 doesn't work, meaning that's the answer. You cannot get minus 2 because f of 2a, the 2a can be anything. So you are just confirmed to have only values that are greater than or equals to minus 1. Okay, so at the back of my mind, I'm also aware that the hyperbolic cosine function satisfies this condition as well, and that could possibly have given me the answer. But I was trying to use something a bit more familiar to everyone, so I think the standard cosine function gave us some headway, and then actually that's not necessary because we could have just used this functional equation substitution approach. But again, for the AMCs, don't forget that eliminating options is quite a good thing. So if you can eliminate A, B, and C, and then you're left with D and E, you could guess. And personally, I would guess negative 2 to be more likely to be impossible than 2 just from good old-fashioned gut feel and intuition. But even just eliminating 3 options is always a good thing. Okay, question 23. When n six-sided dice are rolled, the product can be any of 936 possible values. What is n? That's weird. Um, that is interesting, but a little bit weird. Now, the product depends on prime factorizations, right? So 1 is basically going to be nothing. 2 is just a 2. 3 is just 3. 4 is 2 squared. 5 is 5, and then 6 is 2 times 3. Now, in terms of the number of 2, 3s, and 5s, another way to think about it is that you have got as sort of like vectors, right? 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, and then you have got 2, 0, 0, and 1, 1, 0, and then you are adding these and seeing how many combinations you can get. Now, they would obviously not be that many different ways, so I want to do a little bit of bounding, right? So if let's say that I have n of these, how many different combinations can I get, first of all, of 1 to 6? So that will be equivalent to splitting n into these 6 categories, which is splitting n into with 5 partitions. That would be n plus 5 choose 5 combinations, right? So this is to just give us a bound first. Uh, I feel like each additional die makes you have a lot of extra possibilities. So if we have got 11 choose 5, just to see how big this roughly is. 0, so 42 times 11 is 462. Okay, so this is way too small. And then 13 choose 5. This is 99 times 13. This is 1287. Okay, so it is in the ballpark of getting close to 936. Now I say in the ballpark, of course, there are lots of combinations that are actually the same. So I just want to know how far off are we. Right, lots of combinations. For example, if I use just 2, 3 with a bunch of ones versus 6 with a bunch of ones, that's actually the same thing. Okay, so let me think about what's the best way to do it, because 8, 9, 10, 11 are all quite close. So I don't think I can just do a blind bounding. I need to do something a little bit more um, clever than that. Yeah, I think we probably just need to count directly, right? So it's basically different combinations of these. Um, you've got 1, 0, 0, 0, 1, 0, 0, 0, 1 are effectively the same thing. Uh, maybe I'll just write it. This is the number of 1, 2, 3, 4, 5, and 6. I'll just call it A, B, C, D, E, F. And so that means that the total number that I get in my prime factorization, B you give, sorry, 2 will get B, 2, D, and F, 3 would get a C and an F, and 5 would just get an E. And that's all. And the restriction is that A to F sum to N. And A doesn't appear here, so really it's just B to F sum to at most N. Okay, now that I've done that, now what? Now, if this were actually in competition, I'll probably just skip this question first, right? But since I'm doing a review, I'm going to think about it for a second to see how I'm going to do this. As I say, this is a live solve, so almost live solve, including realizing a typo in my question. Yeah, that's the number of possible values, right? It's just how many you can get to. So it's basically these three quantities. How many different combinations can you get to? Okay, let me erase this because that bound only eliminated 6, but it's not especially useful otherwise. Okay, so if I'm pushing up the value, it means that I want to know how many I can get. That means, what does that mean? That means the maximum of your 2s and 3s can go up because of this and this. Your 5 is limited by n. Okay, let me try something, right? So I'm going to try just ignoring these two first and just using the 1, 2, 3, and 5. So if I just use the 1, 2, 3, and 5, meaning that these are different outcomes, it's basically I just get 2 to the B, 3 to the C, and 5 to the E, where B plus C plus E is at most N. Now this one I kind of knew already that I will get uh, A plus B plus C plus E equals to N. So using the same partitioning argument as just now, this will be N plus 3 choose 3. This is just starting from here, all the different combinations that I want to potentially have. This is not going to be enough though, because this is very few. You can see that I'm pausing here. This is actually an interesting question. The only trouble is that I'm not sure if it's interesting nice or interesting complete nonsense. Right? And I've taken a glance and seen that the question after this is quite straightforward. So yeah, I think I will just go with um, the approach that I have often suggested, and I am reluctant to use because, well, looking for a nice solution. But I think I'll just look for a pattern. I've said this before in the AMC conditions, look for a pattern. So I shall do that myself, right? If n equals to 1, there are 6 possible values. If n equals to 2, should I follow this or do I follow that? I think I will just write down all the possible numbers just humanly. This is very low tech, but I feel it's actually quite fast. Okay, so there's 6, 7, 8, 9, 10, 13. There are 18 possibilities down here. Okay, so now I can't really list n equals to 3, can I? This is not very realistic. So I'm thinking about a pattern, right? Now writing a pattern out is one thing. As I'm writing the pattern, I'm trying to see if there are any efficient ways that I can actually go about doing this. Okay, I feel like the fives are the easiest to handle, right? The fives are just something that we can fix. So what I can do is to sort of say that, let me see how many fives I pick, and then assume that I'm just working with the other dice at A, B, C, 1, 2, 3, 4, and 6. So A, B, C, D, and F. Okay, so this pattern's a bit too crude. Maybe we will just use it as a reference that n equals to 2 is 18 later. So suppose there are, let's say, just m of your 1, 2, 3, 4, and 6, and n minus m fives. Okay, so I'm using 1, 2, 3, 4, and 6. I want to find out what is the number of possibilities that I can get using m of these. I can just list that out, like the maximum is 2 to the 2m, and then for 2m minus 1, I can have 3, 2 to the 2m minus 1 without a 3. If I did 2 to the 2m minus 2, the maximum I can have is that I can replace the 2 with a 3 in the maximum. So your degree can be up to um, a total of 2m. And I can get rid of a 3 by using the 100. So I think that's probably it, right? Just go down and list it in this way. Now, this continues all the way until 2 to the m times 3 to the m all the way to just 2 to the m. But below that, I can never get more than 3 to the m. So all the way down after that, if I go 2 to the m minus 1, it still goes 3 to the m all the way to that. And then finally it ends here. Okay. So at the end of the day, I think I was looking for something too clever. This has there's 1, 2, all the way until you get to m plus 1, and then you get another bunch of m plus 1s. Okay, so it's 1 to m plus 1 squared. Okay, now I am basically going to just have to sum this over all the possible values of n minus m. Let's just expand this bit out again. I realized there was no point doing this because now I'm going to sum as this m goes from 0 to n. And I don't think it's going to telescope, so I just go straight for it. And m equals to 0. That's the only place where this 1 comes in. For the others, it's just as good as summing from 1 to n, so I can use the usual formula. So there's obviously a factor of n plus 1. And then I have got a moderately sized mess of terms to deal with. So n plus 1, 2n squared plus 6n plus 4 over 4. This is n plus 1 times n squared plus 3n plus 2. Oh, so this actually is quite nice. That's a surprise. Okay, so I can use the answer options, right? It's n plus 1 squared n plus 2 over 2. If I put in 8, 9 squared, okay, this is definitely not going to contain a 0, so or 5, so it's not this, it's not this. 11 squared, this is not divisible by 11, so it should be this. Yeah, so after taking way too long to do this, solution's actually quite simple. Live solves usually will involve me doing something like that, which is meandering all over the place and trying all kinds of things, right? So apart from bearing with me, the other thing is to see that you should definitely skip a question, because one look at the next one tells you that that's a lot easier. How do we do this one is just by matching powers, right? LCMs, and all of them just contain 2, 3s, and 5s. So unlike this 2, 3s, and 5s, this is just a mini game. So you've got 2s, 3s, and 5s, and I'll just use it as like a table where we just need to fill up. Okay, so we'll just do the 2s, 3s, and 5s one by one. Now the 2s and 3s, the B and C just give you a 1, but the LCM of A and C is 3, so this is a 3. The LCM of B and D is 2, so this is 2. And so I can see that there is 1 left over, so this would be 1 and 0 in some order, which doesn't really matter. Do you like that? Now the next one, the LCM of A and B in the 3 column is at most 2. So these are at most 2, but combining with C and D both give you 3 cubes. So there's a 3 here, a 3 here, and at most 2, they sum to 9, so this would be 1 and 2. Now same with the 5s, the B, C, and Ds all give you at most 2, means that A is 3. They sum to 4. It cannot be 1, 1, 2, because the pair of 1s would have given you a 2. So it has to be 0, 2, 2 in some order. And that means that when you take the GCD, you just grab the 0, the 1, and the 0. So it's 3 to the 1 is 3 is your answer. So it's not infinitely easier than the previous one. So again, this is the reason why you should skip questions in the AMC. Last one, 25. I know this is the same as the AMC10B final question, but actually it's not very difficult. It's just, well, technical. Let's draw a pentagon. regular pentagon with area root 5 plus 1. I don't know why I want to care about that. Um, it's probably something to do with the cosine of 36 or 72. I can't remember the values, but I know it's something to do with root 5 plus or minus 1. The 5 vertices of the pentagon are folded into the center of the pentagon, creating a smaller pentagon. Okay, so the center of the pentagon, I'd like to draw a circle around it just for the purpose of seeing the center. And then I fold it around, meaning that uh, that's not quite it. Maybe something like this so that it looks like this is just folding. Now, the question I have is that when we are folding into the center of the pentagon, this is not quite at the midpoint. So if this is not quite at the midpoint, you are going to actually end up with something like this, where I think they do overlap in a rather strange way. Let me just think about it. I'll just draw what I think it looks like first, and then I will just check my understanding of the question one more time. So my understanding is you end up looking something like that. And then the pentagon is actually the thing in the middle. But let me just think about that for a second. So printed on paper and cut out, the 5 vertices of the pentagon are folded into the center of the pentagon. I think that's probably what it means. Yeah. Okay, yeah. So I think this is what it means. Yeah, I find it a bit weird because when you're folding, how this actually look like? Um, like, wouldn't that be a bit of a messy pentagon? But well, I think this should be probably it. So area of the new pentagon. Okay, I'm doing this as an AMC 12 review. I know it's the AMC 10. So definitely it can be done without trigo, but this is very tempting to do with trigo. So I'm going to try to just see what representative length I can try to find, because I don't really want to find the length of this pentagon, do I? Maybe I do, but let me just think about it for a second. Yeah, so I think the point is that I drew a circle around it, and I realized I don't want to draw another circle around it, but this would be the radius of the small one, and this would be the radius of the big circle. And the thing is that I can compare them because by the definition of folding, this is actually just equal. Also by symmetry, I know that these angles here in my pentagon are going to be 36 degrees because it's half of 1/5 of the 360 degrees. So if I use the radius to compare, it means that, okay, let's call this thing here, uh, this is x and x. This here is going to be x over cosine 36. So your area is going to be x over cosine 36 over 2x. So area ratio is going to be this, which is 1 over 2 cosine 36 degrees squared. And I would need to multiply that to root 5 plus 1. Now, I said a moment ago, I don't really remember what is cosine 36 degrees. I generally do not. I think it can be done using some similar triangles, but I recall a different method that I always like to share, which has something to do with 36 and 72 degrees, right? Or 36 and 18 degrees, whatever it is, something to do with one of these. So basically getting a pair of equations that looks like that. Actually, I think I um, prefer the other combination, which is to use 1 minus 2 sine squared 18, which is 1 minus 2 cosine squared 72. So I can just use the cosine double angle twice. So use this and this together. I call this x and y. Means that x equals to 1 minus 2y squared and y equals to 2x squared minus 1. Why I remember this is that when you add the two equations, you can divide by x plus y and find this identity, which is x minus y is 1/2. So cosine 36 minus cosine 72 is half. I remember it's the one that uses two cosine roots, so I wasn't sure if I should use 36 or 54 or 18, but a bit of experimentation has reminded me it is this. So I want x, so I can substitute in y equals to x minus half into here. So just a good old-fashioned quadratic formula. So 1 plus or minus the square root of 5, but it has to be plus because, and this is over 4, right? But it has to be 1 plus square root 5 over 4 because I expect it to be positive. Okay, and so your answer is 1 over 1 plus root 5 over 2 squared times, well, very conveniently, 1 plus root 5. So it will equate to root 5 minus 1. Okay, so and that's it. This took a bit longer, mainly because of me getting stuck on question 23. As I said, this is a live solve, and some of these are a bit more difficult, I feel. So it still isn't the hardest, but compared to the 12A and the 10A, certainly, this back end is less straightforward and also a little bit more time consuming because there are a few different variable approaches. At the same time, there's something like question 24 which can be done. So I don't really have too much more to say except for one final reminder if you just fast forwarded the first 5 minutes of this video, which is that the answer options are not in order. And so if you have a different set of answers in terms of letters, don't worry, just make sure that your numerical answers are correct. And that would be, of course, what the MAA will check as well. That's all for me from now. Let me know in the comment section below if you have any other suggestions or any other alternative methods for any of these other questions. And don't forget to like and subscribe for more content, which will probably be moving over to the AIME in the coming weeks. Thanks again, and see you again soon.